Okay, here we have write and graph the equation of a vertical line that passes through 1 and 4. Also write and graph the equation of the horizontal line that passes through the same point. Let me remind you that in class announcement, when you look at the previous sessions, I also have a link to workshops, like a mini sessions about different topics. And I recently prepared some workshops about graphing, and it would really help you if you view those sessions as well. So make sure you review all these old sessions, and especially these workshops that would help you with this. So let's take a look at the graph of the equation for the vertical line. Let's take a look at the graph and see what it's look like. At any point during the session, please, if you have any questions, raise your hand or put the X next to your name so I can stop and make sure we're following. Okay, when we look at the graph of the vertical line or horizontal line, in this case we have a point that's given to us, 1 and 4. So let's locate that point. I see Renee just joined us. Renee, if you can hear me, go ahead and put a check mark next to your name. So if I locate point 1 and 4, x equal to 1, and y is equal to 4, so this would be the point 1 and 4. And we show the point as an order pair in the parentheses. The first number corresponds to the x-axis, and second number inside the parentheses correspond to the y-axis. So we have a point here, 1 and 4, and we want to write the equation of the line that passes through this point that is vertical. So when you look at the vertical line, that should be pretty obvious. That would be the line that we're referring to. Okay. Now we'll start with. Can I see a check mark next to your name if you can follow this so far? If we can see the graph of that so far. Okay, so everybody can locate the point and just draw a line, vertical line, right into that, and that would be the graph. Daisy, if you can follow this, please put a check mark next to your name. Great. All right. Now, can somebody tell me what's the equation of this line would be equal to? If you know it, just put the x next to your name. Okay. Daisy, can you tell me what's the equation of the line? Okay, how about this question would be for anyone? Anybody know the equation of this line would be equal to? Just type it. Okay, Daisy, this is where you get lost on that. Now remember the equation of the line. To write the equation of the line, we need to know 2 points. Okay, we already have 1 point, 1 and 4. Can somebody give me another point on that line? Okay, how about this point here? What does this point correspond to? Looks like just by looking at the graph, I can see another point. Can somebody put the position of this point for me? Okay, this is 0. this is 1, this is 2, and so on. And this point here is 1. So Heidi says 0 and 4. No, I'm looking at the position of this point right here. Can somebody tell me what's the position of that point? Okay, just like we have here, 1 and 4, we go from 0, we go 1 to the right, 4 up, so that would be 1 and 4, this point. Let's call it point 1. I can find another point, and the position is right here. So anybody can tell me what it is? Okay, the 0, 1. Now the first number corresponds to how far you move on the x-axis, and the second number in the parentheses in the point correspond to how much you move on the y-axis. And Daisy says 1 and 0. That's exactly right, because we're moving 1 unit on the x-axis and we're not moving up at all, so that would be 1 and 0. Can I see a check mark next to a woman's name? Everybody can follow locating a point on the graph, first of all. And these are the type of things that would benefit you if you view those old the sessions that I already have on graphing, because we spend time going over locating points and graphing points. Okay, and Renee said, what doesn't it look like 0, 0? Okay, the position of 0, 0 is right here. This is where the 0, 0 is. This is 0, 0. This is the point 0, 0. Where the origin is. 0, x-axis, you don't move anywhere, and that's where the 0, 0 is. But when you move, remember that's a graph. Continue that. That's your graph. Okay. Okay. Somebody said there's something wrong with the screen, so let me go ahead and do this on the clean screen one more time, so we can see it. Okay, we're talking about this is the number line here. This is the y-axis. This is the x-axis, and this point here is the origin, which is 0, 0. And 1 and 4, this would be 1. You go 1 unit on the right on the x-axis and 4 units up. 1, 2, 3, 4. So this would be 1, 4. That's the position of the point that's given to us. Okay, let me go back again. Everybody okay with this so far? We can locate this point. Can I say check mark next to your name if you can follow that much? Okay, great. All right. So if I draw a vertical line through that point, then I can find more points on that line. Let's draw a vertical line through this point. So this is the line that we're talking about, the vertical line that passes through point 1 and 4, and that goes forever. Go up and down forever. Okay. All right. Can I see a check mark next to your name if you can follow the line? If I have a vertical line that passes through point 1 and 4, that is the line would look like. Let's go slowly in this. Make sure we can follow that. Okay. Renee, Leanne. Okay. So everybody can follow the graph of the line, vertical line that passes through point 1 and 4. Now my question was earlier, can somebody show me another point on that line? And I just point at this point right here, and I said, well, I can see my graph passing through this point, and you see why this point here is the position of this point would be 1 on the x-axis and 0 on the, because we're moving up. So that would be the position of that point. Okay, Daisy, exactly. So once I graph the line, a vertical line, then I can find as many points I like on that line. There are more points I can point at here. Let's pick another point. There's just another point here. How about this point right there? Okay. The first number here always corresponds to how far you move on the x-axis, and the second number would be how far you move on the y. So if I call this point 1, okay, 1 and 4, again the first number in the parentheses always correspond to how far you move on the x-axis. The second number corresponds to how far you move on the y-axis, right or left. If it's positive, it would be to the right. If it's negative, goes to the left, and so on. Okay, so let me make sure that I see some questions coming up here. It looks like most of you you're getting this. That's good. All right. So yeah, Daisy, you already gave me this point here. So this point here corresponds to, if this is 2, so this point here would be 1 and 2. Let's call this another point, point 2. And let's call this point 3. I can find infinite points on this line. All right. Can I see a check mark next to everyone's name? Make sure we can understand up to this point. So that's all I did was I located the given point, which was point 1, and then I drew a vertical line through that, and I just noticed that I see more points on that line because I need more points to write its equation. I need at least 2 points to write the equation. Okay, now Renee says anything exactly y is equal to k, x equal to k means vertical line. Well, one of them means vertical line, one of them means horizontal line. So we're going to look at that in a moment. So if I look at this line here, we have equation of the line is equal to, general equation of the line can be written as y minus y1 is equal to m times x minus x1. And also there's another one we have is y is equal to mx plus b. Okay, I'm going to box these two, and I want everybody to remember this for the next exam. The first one here is known as slope point formula. The second one is known as slope intercept formula. We're going to talk about that in great detail as how to use these two equations to write the equation of the straight line. But for right now, if I look at in this case, if I have to write the equation of this line, that would be the line that passing through x-axis at 1. So as you see, regardless of what I substitute for y, x is always equal to 1. You see that? If y is equal to 2, x is equal to 1. If y is equal to 4, x is equal to 1. If y is equal to 0, x is equal to 1. So it doesn't matter what I substitute for y, x would be equal to 1. So the equation of this line would be x is equal to 1. X is equal to 1 really means x is equal to 1 plus 0y. The reason that is true is because the y is not there in the equation is because its coefficient is equal to 0. That's why we don't mention it. We just say the equation of this vertical line is equal to x is equal to 1. As Renee was saying earlier, x is equal to k, k being any number, is the general equation of the vertical line. See, well, x is equal to k would be the general equation of the vertical line. So the equation of this line that passes through 1 and 4 is x is equal to 1. That's we answered that question for what we had here earlier. Now we're going to move on to more detail in a moment, but for this question it says write and graph the equation of a vertical line that passes through 1 and 4. So I locate the point 1 and 4, and I draw a vertical line, and I say, okay, all the vertical lines would have x is equal to k. That's the general equation of the vertical line. X is equal to k. So that would be, in this case, x is equal to 1. So if I were going to graph, let's take a look at another one quickly. Graph few more lines. So if this is 0, 0, now if this is 1, 2, 3, can somebody tell me what would be the equation of the line that passing through point -3 on here? So if this is a y-axis, and this is x-axis, and this is -3, what would be the equation of the line, vertical line, that passes through point -3 on the x-axis? Somebody can tell me what that equal to? That would be x is equal to what? No, I'm talking about the equation, not the point. The equation would be x is equal to not 0, because it doesn't pass through word 0. It's passing through point -3. X equal to -3, very good. Daisy. X equal to -3. That would be the equation of the line that passes through point -3. Let me explain this one other way, make sure we can follow this. If I ask you to graph x is equal to -3, then how would you do that? Wouldn't you say, okay, this is the same as x is equal to -3 plus 0y, but the reason y is not there is because its coefficient is equal to 0, right? So in this case, if I wanted to graph this, I need a couple of points to graph this. So let's take a look at a couple of points on this graph. This is x, and this is y. So if if y is equal to 0, all right, Daisy, can you tell me what x is equal to in this equation? If y is equal to 0, Daisy says equal to -3. Very good. So if y is equal to 0 in this equation, x equal to -3. All right, Erica, if y is equal to 1, can you tell me what x is, Erica? When I ask you guys a question, if you don't know it, just put the x next to your name so I can move on. But if you know it, just type your answer. So this question is for Erica. If x is equal to if y is equal to 1, Erica, what's your answer? What would be x is equal to? -3. Very good. You see that because the coefficient of whatever number I assume for y, when I multiply by 0, the result would be 0. 0 plus -3 would be -3. Okay. All right. I see x next to machine. All right. Okay. I guess you got it. All right. So it doesn't matter if I let if y be equal to 100. X would be equal to -3. Can I see a check mark next to your name if everybody can understand this concept? Because if you do understand this, then graphing vertical and horizontal line would be pretty simple. Okay. Adams, what is your question? What is it that you don't understand? I see X next to your name. Okay. Let me do a little calculation here. If maybe that would help you. If y is equal to 1, then in this equation here, x is equal to -3 plus 0y. So if I substitute for each y 1, and I solve for x, you see clearly that x would be equal to -3. This is plus 0, so x is equal to -3. It looks like you got it. You change your x to the check mark, so everybody can follow these calculations. So if I were going to graph this, okay, let's go ahead and find a couple of points. When you graph a line, you need only 2 points. So let's go ahead and graph those 2 points. Let's find this point here. Let's call this point 1. Let's find this point here. Let's call this point 2. So here I have point 1 is -3 and 0. Let's locate that on this x and y axis. So if x equals to -3, so this is 1, 2, 3 to the left, so this would be the point 1. Okay, and let's pick the second point, point 2, -3 and 1. So -3 and 1 would be right on top of each other. And as you see, because the x number is the same for all these points, this refer to all these points would be right on top of each other. These are the 2 points. So if I'm going to graph this, to connect these 2 points together, that confirms what we just said earlier. That would be the line that passing through points right there. So that is, well, that is what x is equal to -3. Can I see a check mark next to your name? Would you understand the graph of vertical line? As you see, as I said earlier, is again the general equation of that would be x is equal to k, as Renee said earlier. That means if y is missing, that means we are looking at a line that is vertical and that passes through point k, whatever k is. So the line that passing through right on 0, right on top of the y-axis, the equation of this line would be x is equal to 0, and this is x is equal to -3, and then if I draw another line here, let's say here, this would be, let's say this is 4. So this would be x equal to 4, and so on. Okay, in this example that we had earlier, that's all they asked us to do was to draw the line, a vertical line, that passing through this point here, 1 and 4, and we wanted the equation of that. So we clearly can draw that, and then we would say the equation of this would be x is equal to 1. Okay, it looks like everybody got that. Now, the horizontal line would be very similar to this, except, as you probably can guess, that would be where x is missing in your equation. So let's take a look at that as well. So if I have Daisy, you have a question. So you're saying that so if x is equal to 2 and y is equal to -3, and the second point would have to be within that line, whether number y would be right. What I'm saying is basically if you have equation where you have like x is equal to k, when y is missing in your equation, it means we're looking at the vertical line. So x is equal to 0, x is equal to 4, x is equal to -3. These all represent vertical lines, as we looked at, and that would be the line that passes through point K on that x-axis. Daisy, do you follow that so far? If you follow that, you can put the check mark next to your name. And I'm going to start the next one. Okay, very good. Looks like you follow that. Okay, so the next one, let's say we have an equation y is equal to 3. Okay, let's just take a look at this one. Let's say we wanted to graph this. Graph y is equal to 3. And we already know the general equation of the horizontal line, y is equal to k, it looks like this. So we know in advance now. But in order to graph this, look what we have to do. We need a couple of points again, right? So I can go ahead and write this as y is equal to 3 plus 0x. It's very important to, at the beginning at least, to change that into this form. Y is equal to 3 plus 0x. So when I'm looking for a point, I know where my x and y's are. Otherwise, it's a little confusing at first, and the one variable is missing. So in this case, when I make a chart like this to find a couple of points, I say, okay, if x is equal to 0, what is y? Okay, anybody quickly give me what y would be equal to if x is equal to 0 in this equation? Okay, Renee says 3. Very good. All right. If x is equal to 1, what is y? Still is 3, right? Okay, Renee, what is 0? If x is equal, remember, y is equal to 3 plus 0x. If I substitute for each x 1, right? Oh, you got it. All right. So then obviously y would be equal to 3 plus 0, which is 3. Okay, so again, here is regardless of what I substitute for y this time, regardless of what I substitute for, delete some of these extra lines I made here. Okay, regardless of what I substitute for x, okay, I can let x equal to 100, y would be always equal to the same number 3. So when I graph this, if I find a couple of points here, this is y, and this is x, let's locate that. If x is equal to 0, y is equal to 3 would be, this is the point 1. And let's call this point 2. If x equal to 1, y is equal to 3 would be, now this time all the points would be right next to each other, as you see. So that would be represent a horizontal line that passes through point, in this case, 3. So this would be y is equal to 3. As you see, all the numbers on this line which share the same number for y. If x equal to 1, 2, 3, all the way to infinity, always y would be equal to 3, and that's why the equation turns to be y is equal to 3. Can I see a check mark next to your woman's name if you can follow this concept as well? It's very similar to the vertical line. So that's why we said y is equal to, okay, so in this, very good. In this example that we had earlier, they were saying that we want to have a, let's go back to that example again. Okay, here we want to write the equation of the horizontal line that's going through the same point here. So still the point is the same right there, and I can graph them easily by drawing the line like that. So that would be, the equation of that would be y is equal to what? Y is equal to what, anybody? What would be the equation of this line? 4. Very good. Y is equal to 4. Got it. So these are the equations that they were looking for. Y is equal to 4. That's the equation of the horizontal line. X is equal to 1. That's the equation of the vertical line. Both of these lines passes through point 1 and 4. That was the question number, the number we're working on.